Hi, good morning. Good morning, everyone. It's 11 o'clock sharp. We are talking on very important topic, medical equipotential bonding and earthing for hospitals. Today, 4th April 2026. This is our 11th webinar in last 3 months. So I would like to just introduce you NFE, those who are not aware of National Federation of Engineers for Electrical Safety. I would like to invite you to understand NFE, which is we just completed 3 years as one of the fastest growing society in India, over 3,000 members and 13 chapter across India. This is the only society for electrical engineers in India. So, what are we? We are here to create awareness on electrical safety and fighting today for better tomorrow. And the vision is very clear to make every electrical installation free from accidents. Mission to strive hard to through getting accredited for products and personal certification. We should focus on electrical safety by design, manufacturing, installation, and maintenance of electrical product. If you follow us regularly, we are continue to do a lot of certification program for electricians, electrical engineers, contractors, consultants. What we have been doing in last 3 years is traveling length and breadth of the country. We completed 59 workshop across India in last two and a half years. We conducted over 200 webinars in last 2.5 years. And the aim is to create awareness and improve the skills of practicing electrical engineers, improve electrical safety measures followed in the industry, introduce modern safety measures in engineering, and improve quality of electrical installation. I would urge everyone to become a member because there's huge bank of information. Knowledge is available in our website with all the recording of previous webinars on various subjects are also available in our website. You can access only if you are a member of NFE. So I would request you to become a member. If you are an individual member, it's just 1,000 rupees a year. Corporate member, it is 5,000 rupees, and MSME 2,500 rupees. I invite you to become a member, and we have a corporate video which I would like to. We have some technical issues, but I like to try my best once again to play the video, corporate video of NFE.
Electricity is the heartbeat of modern India. It lights our homes, powers our industries, runs our hospitals, and connects every corner of our nation. Yet behind every switch and circuit lies a silent responsibility, the responsibility of safety. Every year, thousands of electrical fires and accidents remind us that one loose connection can change lives forever. According to national data, over 25,000 electrical fires occur annually, claiming lives, destroying property, and halting progress. Most of them could have been prevented through better design, better supervision, and better awareness. The country witnessed repeated accidents and increase in casualties due to poor installations, lack of inspection, and absence of accountability. They decided to take action. Thus began a movement, the National Federation of Engineers for Electrical Safety, NFE. Started with a small group of like-minded professionals with only passion and purpose. They began spreading awareness through webinars, workshops, and training sessions, one city at a time. What started as a conversation soon became a nationwide movement for safety and change. In just a few years, NFE has grown into one of India's fastest-growing engineering societies, uniting over 2,500 plus engineers across 12 chapters in India. Each chapter drives its mission through learning, collaboration, and public awareness campaigns. NFE has conducted over 180 webinars and 50 workshops on the National Electrical Code of India in collaboration with the Bureau of Indian Standards, BIS. These programs are helping thousands of engineers stay updated with safety codes, best practices, and new technologies. NFE's signature annual event, ElecSafe, brings together government leaders, consultants, manufacturers, and innovators. It celebrates best practices and showcases electrical safety products that make buildings and industries safer across India. NFE's student chapters inspire young engineers to design responsibly, while its professional programs help experts achieve certifications that matter. Together, we are building a new generation of engineers who think safety first. From a humble start to a national movement, NFE continues to lead with integrity, commitment, and purpose. Because electrical safety is not just a regulation, it's a responsibility. Together, let's build an electrically safe nation. National Federation of Engineers for Electrical Safety. Join NFE as a crusader for change, spreading awareness, training professionals, and advocating compliance.
Okay, that's the introduction of NFE for you. And today, I don't like to, bring this conversation much. It's very important. The part two, we had 10 days back, part one as webinar on fire safe hospitals. And I think is something that which we are very, very keen to implant knowledge on how to design safe hospital through proper earthing. So I have a speaker, a well-known face to all of us today, and is the founder of Cape Electric Private Limited, Cape Electric Power Productions, and LP Consultant International Private Limited. He is a very active member in BIS and IEC, and a member of ETD 20, ETD 30, ETD 50, and also the National Building Code 2025. It's the part 8 Electrical Committee. He is also a member of IEC TC 64, TC 81, TC 37. He's playing an important role in IEC member NT 40 medical locations, which is part of IEC TC 64. So I welcome Mr. Gopakumar for the second part of hospital safety. Over to you, sir.
Thank you, Mr. Dominic. I hope my sound is clear. Can you allow me to share the screen?
Yes, sir.
I hope my screen is visible.
Yes, sir. Yeah, the sound is little bit. It can be better if you can come closer. Yeah.
Okay. Is it better?
Yeah, much better.
Okay. Thank you. So let me switch off the video. Good morning, participants. 2 weeks back, we held the webinar on handling fire safety in hospitals, and today we are going to discuss about protective earthing and functional earthing. During the last webinar, there were so many questions in the chat box as well as in the Q&A about earthing. That is the reason we specifically thought of making a webinar on the subject of earthing. Now, just a minute, let me check the audio, whether I can increase the sound. I hope my sound is very clear.
Now better, sir. Now better.
Okay, thank you. So, yeah, so today we are going to discuss about protective earthing and functional earthing. When we talk about the subject of earthing, first of all, we should understand that earthing is related to two important subjects in a hospital. Protective earthing, which is for safety of people and the property against shock, against fire, against electrical equipment failure. And the second subject is functional earthing. Functional earthing ensures that all the electronic equipment are working properly so that there is no communication lag between electronic equipment. There is no problem for the electronic equipment during changeover from mains to the generator or so on. So these two are two different subjects. Now, coming to the subject, last week we discussed various subjects such as the challenges which we are having in the hospital with respect to electrical subject, but I will quickly go through it. This was explained in the last webinar. The challenge here is the patients may be undergoing surgery and they are in life-saving equipment. So any disconnection of supply will be a disaster. So continuity of supply is very much essential. Even if we have generators, multiple UPS, multiple transformers with automatic or manual changeover, sometimes continuity of supply cannot be ensured if there is a fault. During fault, continuity of supply must be ensured because all the medical electrical equipment are capable of working under single fault condition, or they are able to ensure safety under single fault condition. Then the equipments are with conductive metal. There are wet floor, high chance of electric shock and arcing, oxygen rich environment, presence of alcohol, patients in life-saving equipment, many ill patients in the affected environment, severeness of the hazard with respect to fire and smoke is too high, skin is bypassed, conductive instruments are in contact with the bloodstream of the patient. So continuity and the safety of the electric supply is very much essential. Also single fault condition and the complexity of handling fault and continuity of supply during single fault condition is a little bit complex. Incorrect electrical classification of medical areas, earthing and equipotential bonding, mismatch between equipment requirement and installation, power quality and supply variations. These are some of the challenges, but the list goes on adding more and more, like electromagnetic compatibility, aging infrastructure, inadequate ventilation and periodic testing, human factors, operational risk and untrained staff, regulatory awareness or unawareness, space constraints. There are many challenges. There are challenges from the distributor, means the DISCOM, the electricity supplier, non-standard supply, high transfer potentials, extremely high touch voltages. DISCOMs are beyond the control of safety department and so on. So these challenges we already discussed. The important point today is earthing is a subject which influences all these safety measures. Earthing influences all these safety measures. So what we should understand carefully is it is extremely difficult to switch off the power supply in a hospital to make a study or improvement. Even if you wanted to make some kind of a study, you cannot switch off power supply in an existing hospital because thousands and thousands of machines, electrical equipment may be connected to the patient, life-saving equipment, continuously patients are coming. In my experience, sometimes if we wanted to make an improvement in a hospital for some reason, sometimes we may have to do it during midnight or during Sundays. It's extremely difficult. The switching off is extremely difficult. So during the construction itself, please ensure that all the safety requirements and compliances are 100% met. Initial verification is 100% made before you starting the electrical installation. Earthing is a subject which influence all these safety measures. First, quickly let me go through what is the wrong concepts of earthing which is followed in India. Separate earth pit for different electrical items, such as 2 earth pit for neutral of a transformer, neutral of a DG, neutral of UPS, 2 separate for body, 2 separate for main distribution board, lift, and all. This is absolutely illogical, and this is totally against the concept of electrical safety. So Unfortunately, even today, a lot of hospitals which is made even in the 21st century go behind this non-standard method, which is actually creating disaster, and it can create disaster in the hospitals in future. Similarly, the concept of clean earth, power earth, lightning protection, separate earth. This is a big mistake. Also separate earthing and everything interconnected under the soil, and thinking that this will provide a safety is a big mistake. Earthing is not a subject which is talking about earth electrode. The term earth itself means you are making a connection to a local earth, not to the earth pit. Earthing and earth pit are two different subjects. In some of the projects, one of the trend which we always see is, especially in large projects, always electrical engineer wanted to make a calculation of an earthing. And then there are, calculation as per IEEE 8. Please note, IEEE 80 is a IEEE guide for safety in substation grounding. IEEE, it's a guide for safety in AC substation grounding. IEEE, if you look at the website of IEEE, of course, IEEE standards are extremely good, very, very good standards. But the problem is we are applying it in a wrong way is the point. Example, if you go to IEEE website, you can see that IEEE makes standards, which is documents with mandatory requirement. Second is recommended practices. Third is guide. Guide published by IEEE. The definition in IEEE website is documents in which alternate approach to good practices are suggested, but no clear-cut recommendations are made. So, IEEE Guide for Safety in AC Substation Grounding, it's an alternate approach to good practice. That means there is already a good practice existing. And this IEEE 80 is suggesting an alternate approach, but no clear-cut recommendations are made. The standard, this is the definition of the standard. So please be very careful while making an earthing based on IEEE 80, especially for a hospital. First of all, please note that this is not applicable for an earthing system in a medical location or in a hospital. What I mean to say is, normally the fault current 50 kiloampere, 65 kiloampere and the low voltage side of a transformer has been asked by the consultant. Says, I have two transformers, 2500 kVA, 1000 kVA, 50 kiloampere fault current is expected. You make a grid for 50 kiloampere fault current for a LV system, then people run behind the IEEE 80. And here the challenge is the manufacturers, they make big claims, in the sense earthing experts make big claims. There are companies, those who are experts in lightning protection, they say, I am the best in earthing. And finally, what happens is unnecessary requirements are being included, and all of us end up in trouble. Earthing is not a subject which is explained in one book. Earthing is explained in multiple standards because there are so many requirements in a hospital. Example, medical equipment and requirement for medical equipment. Medical electrical equipment, which we generally say biomedical equipment, they are classified as, there are class 1 medical equipment, class 2 and class 3, like any other electrical equipment. Class 1, class 2, class 3 type of medical electrical equipment or medical electrical systems are there. They are classified in IEC 60601, the main standard. Equivalent Indian standard is IS 13450. Applied parts means the parts of these electrical biomedical equipment which is touching the body of the patient. A requirement of earthing for these biomedical equipment are very much explained in various clauses of IEC 60601. Example, clause 16.9.2.2, protective earth connection in medical electrical system. I have highlighted some of the point where the pathway of fault current caused by a live part to a protective earth part is protected only by supply main circuit overcurrent release. The protective earth resistance of that pathway shall not exceed 200 milliohm. 200 milliohm is the resistance required for a certain application. Now, in another application, part of the fault pathway may exceed 200 milliohm, but shall be less than 400 milliohm. So, always there is a requirement of maximum resistance for the particular equipment, depending upon the type of equipment which we are using, as well as depending upon the power requirement for the particular medical equipment. So these are the subjects of IEC 60601. That means if you wanted to construct or make an audit in a hospital, first you should be aware of the type of medical electrical equipment. The type of medical electrical system means medical electrical equipment means one equipment of biomedical or one single piece of biomedical equipment. Medical electrical system means multiple biomedical equipment integrated in such a way that all of them together are making one function. Maybe the vital body functions are supported by multiple equipment. The standard further, subclause 16.9.2, you can further see all protective earth conductors and power supply cords should be routed together. In earthing or in electrical engineering, or electrical installation, it is always a mandatory requirement that all the live conductors as well as the protective conductor shall be routed together. It should run together. All protective earth conductors and power supply cords should be routed together. Here also you can find out the same clause. It is unacceptable practice to connect multiple socket outlets in series. So then the requirement of earthing, you can see here 200 milliohm, 400 milliohm. You can find this requirement in multiple places of the same standard. A touch voltage can appear on earthed conductive accessible parts of an extended time if the protective earth resistance is greater than 400 milliohm. This is in a location you have a biomedical equipment and sometimes the resistance required is less than 400 milliohm for an equipment which consumes power or having a fuse of up to 13 amperes. If the machine requires higher current, then of course the resistance decreases. So what I wanted to explain is each of these biomedical equipment require a different a type of earthing requirement is there, which is very well explained in the necessary standard, biomedical equipment standard, which is IEC 60601, but there are several associated standards. And if you look at the marking of in this equipment, there are different type of markings which is included. The first one, 5017, the generic symbol which we use to identify earthing. This is actually a symbol which has to be put in an equipment to identify that an earth terminal in case where neither the symbol 5018 or 5019 is explicitly stated. So this is for certain purpose. 5018 is called as functional earth, which was also called as noiseless or clean earth terminal. 5019 is called as protective earth. 5020 is called as chassis earth. 5021 is equipotentiality. So like this, multiple applications are required and these are the part of the necessary product standard. Sometimes you have a biomedical equipment which is not communicating, which doesn't have any electronics, which doesn't have any communication. In that case, you need only 5019. If you have maybe another equipment which is working with DC and probably communicating, which has got electronics which is communicating, then you don't need 5019, but you need 5018. So you can find these markings in the respective product standard. Example, you can see here the chassis earth, the protective earth. In biomedical equipment, you can find here, I'm moving the cursor. you can find in multiple places, multiple requirements. So some of the examples you can find here near the power cord, there is a the equipotentiality is shown. Equipotentiality is shown. The purpose of making this equipotentiality is between, there should not be any potential difference between the equipment and for example, the bed where the patient is lying. So basically, like the other equipment, normal electrical equipment, the electrical equipment used in biomedical location or ME and MES are also classified as class 1 equipment, class 2 equipment, and class 3 equipment. Class 1 equipment require a protective earthing. Class 2 equipment are no protective earthing is mandatory because these are double insulated devices. You can find this kind of a symbol. Then you have class 3 equipment, which is operating with the extra low voltage. So sometimes these equipment require functional earthing, maybe together, maybe separate. An example is a biomedical equipment which is operating with the 230 volt AC, which is having a communication or which can be connected to a network of multiple equipment. The reference may be the neutral of the power supply, whereas for a class 3 equipment, the reference may be a functional earthing. It may not be the neutral of the system. So depending upon the type of equipment, the requirement varies, and these are very well explained in the respective product standard as well. The product standard, as you can see in the list, example for ventilators, there are multiple type of ventilators, different type of ventilators, and each of these ventilators are made based on a typical standard. Either it's an ISO standard or an IEC standard, and the requirements are part of these particular standards. I'm just showing some example. So basically, the first subject here is the user or the designer must understand the requirement of earthing for the equipment which he is going to use. That means he has to have an expert who understands the technical requirement of all or a different kind of biomedical equipment, discuss with the biomedical equipment suppliers, find out their requirement. Example here, you can see G, one of the particular equipment, maximum line resistance. The line resistance requirements are there, power supply requirements. Whatever I highlighted, all these are associated requirements of earthing. Example, equipotential. Equipotential link will be by means of an equipotential bar. Grounding conductor will be of the same size as the feeder. That means in normal electrical installation, we say the protective earth conductor, if the line conductor is more than 35 millimeter square copper, the line conductor, the new protective earth conductor can be half the size. Whereas for this particular equipment, this is not applicable. You have to size it as per the same size of the line conductor. Another equipment, this is suitable for a TNS system. The line impedances are measured. So basically, these requirements are part of the product standard. So the first job is understand and find out the electrical requirement or the earthing requirement, safety requirement of the electrical equipment which you are going to use in your electrical installation of the hospital. The second, please note that we have only 1 hour. I will not be able to explain all the requirements. I am only trying to explain what is sometimes important. With respect to the system, sources, electrical systems are classified into TN, TT, and IT. TN is subdivided into TNC, TNS, TNCS. Then we have TT, then we have IT. We have made several webinars on this particular subject. How TNS, why TNS, or why TT, why TNCS, and so on. You can look into the videos of our webinars, which is sometime it is allowed only for the members of NFE, of course, but these videos are already there, which explains how to select a particular system for a particular application. Now, once when you select a system earthing, the important subject which you should consider is the first one, disconnection time. Okay, what is the maximum permitted time for tripping the supply? The standard recommendations you can see in this particular table. This table is from IS 732 or National Electrical Code of India, which is this is actually the global the requirement from IEEE 60364 441 standard. The disconnection times used all over the world are the same. Depending upon TNTT IT system, you have to decide. Depending upon the operating voltage, you should decide. Then the second subject is permissible touch voltage in a location. Permissible touch voltage in the sense, what is the time and what is the voltage allowed in a location during a fault condition. Of course, there are certain limits. In hospital, the locations are classified group 0, group 1 and group 2 location. As I explained in the last webinar, one of the first subject which a designer or an owner of a hospital who is going to make a hospital, they have to understand that first job is to classify electrical classification of medical location as group 0, group 1 and group 2 location. Touch voltage requirements varies in these locations. Probably in a group 1 and group 2 location is 25 volt for a longer duration. Whereas for a high voltage fault, maybe 65 volt or maybe 50 volt. So, these voltages varies depending upon the disconnection time. Then there are certain calculations. Example, in case of a TNS system, and if you are using OCPD for the automatic disconnection, then you know very well the ZS calculation, the fault loop impedance calculation. Considering thermal control, the measured value, there is a calculated value of fault loop impedance, there is a measured value of fault loop impedance. And if you are going for a TT system, or if you are using a system for fault protection, you are using an RCD, then there is another type of calculation available. The fourth subject to be considered is transfer potential and power frequency stress voltage and power frequency fault voltage. This is a subject which tells you that in case of a fault on the high voltage side of a transformer, how much potentials and duration are allowed in the low voltage side of the transformer, because finally your equipment are capable of withstanding certain voltage for a certain time. Due to a fault, if the voltages are exceeding, then there will be failure. Similarly, the calculations for IT system during the first fault as well as during the second fault, these are very well documented in the installation standard. Installation standard, please note, there is an equipment standard, there is an installation standard. Equipment standard means the biomedical equipment, because those are the equipment which you are finally going to use in a hospital. Probably there are other electrical equipment as well, such as lift, such as air conditioners, ventilators, and so on. Air conditioners, chillers, and so on, HVAC systems, so many other electrical items are there. One of the challenge which most of the hospitals are facing is challenge with changeover between different sources and in its influence on functional earthing. You are seeing a picture from IS 3043. You have the engine, or you have the generator, which has got an engine and an alternator. Then you have the mains supply, TNCS supply. You have an automatic changeover, and the changeover you can see here with a 4-pole switch. The changeover is happening. Body of the generator is connected to a common bus bar. Neutral is also connected to the same common bus bar. Incoming earth is also connected to the same bus bar. Extraneous conductive parts are also bonded to the same bus bar. This is the recommended method of earthing for a changeover system. Now the challenge is, during the changeover can be automatic or manual, but during the changeover, the neutral reference misses for a short time, because the neutral is missing, the reference, zero reference for the electronic equipment is missing for a short time. Now, if you have class 1 biomedical equipment, which is having a communication facility, and if the equipment is using neutral as the reference of the electronic equipment, the challenge starts because of the changeover. UPSs may trip, PLCs will restart, interference in communication will happen, failure of electronic equipment will happen during this particular changeover. In several places, a lot of people have this particular this challenge. That means once when the mains is off, then immediately you have the generator, but there is a changeover. But during this particular time, some of the electronic equipment are not working. Now, in order to ensure safety of that particular equipment, let's say an UPS manufacturer, the UPS is using incoming neutral as the reference of the electronic equipment in the UPS. In order to avoid this challenge during the changeover, the UPS manufacturer will tell you, I need a dedicated earth electrode. Connect me to my neutral to a separate earth electrode. So, as a result, what will happen is, to avoid one problem, you are making a compromise in the safety, and you are making a non-standard electrical installation by separate earth electrode, and this is going to create accidents and fire in future. You have one problem which is a small problem during the changeover from mains to DG or from DG to the mains. Now, to avoid that particular problem, you are making, or the manufacturer is demanding to make a non-standard electrical installation earthing system, and this non-standard earthing system is going to create a fire and accident in your building. Of course, the best method is, don't make non-standard method. Now, in the same standard, starting from 1987 IS 3043, alternate methods of earthing are being explained. Example, you have, let us say, serial number 1 to serial number 1 to 2, 1 and 2. These are source 1 to source 2. Maybe you have multiple sources in a system. You see the neutral is directly, this dotted line is the main distribution board. The neutral is directly connected to the bus bar through a link. 3-pole switches are used. Then the neutral and the earth bus bar and the main distribution board, serial number 4. This is system referencing. This is the neutral earthing which is made inside the main distribution board. Only one connection between the interconnected neutral point of the source and the PE shall be provided. Now, the advantage of this particular method of earthing, which is also included in IS 3043 since probably 20-30 years, there is no reference missing of the neutral during changeover. As a result, the electronic equipment malfunctioning can be avoided. Number 2, non-standard electrical earthing you need not have to make. So the best alternate is, at the changeover system, you make the changeover system and the neutral earthing of the entire electrical installation in this particular fashion. That means the body of the DG or the transformer is directly connected to the earth bus bar of the main distribution board. You can see here this green color line, the body of the transformer or the DG directly to the earth bus bar of the main distribution board. Neutral of the respective source also directly to the bus bar of the main distribution board. Now the neutral and the earth are connected together. This is the system referencing, or this is the earthing. You have, very easy to make it and highly reliable. Another subject which is again related to earthing is, example, the panel boards, the distribution board. We call it as switchgear and control gear assembly, and the respective standard is IEEE 61439 Part 1. I'm just explaining the protection, the method of protection against electric shock. I have a slide which I will explain later. The following requirements are intended to ensure that the required protective measures are obtained when an assembly is installed in an electrical system conforming to IEC 60364 series. IEC 60364 series is nothing but our IS 732 or National Electrical Code of India, which classifies safety into basic protection and fault protection. Earthing is a subject which is mainly or which is often for fault protection. Now, for a switchgear and control gear assembly, you see here fault protection. When a TT earthing system is being used in the electrical network, one of the following protective measures shall be applied in the assembly. That means your panel board, if your installation is TT system, then you must apply this kind of earthing, this kind of, method has to be applied in your panel board. Example, double or reinforced insulation of all conductors such as incoming cables, extension terminals, etc., up to the supply side of the first RCD in the system, or residual current RCD protecting the incoming circuit. So you are buying a panel board and you are going to use it in a TT system, then you have to take care of the protective device which you are using. This also means if you are going for other system like in a TN system, then the arrangement is a little bit different. A requirement of protective conductors to facilitate automatic disconnection. The same standard IEC 61439 Part 1 clause 8.4.3.2.1. Each assembly shall have a protective conductor to facilitate automatic disconnection of the supply for protection against the consequence of earth fault within the class 1 assembly and protection against the consequence of earth fault in external circuits supplied through the class 1, class 2 assembly. That means there should be a provision for automatic disconnection in every assembly for the internal fault as well as all the external faults. Of course, earthing, the continuity of the protective conductor is very much necessary. The earthing continuity is very much necessary. If you miss it, of course, your panel boards, your switchgear control gear assembly, it will not trip during a fault, resulting in fire or accident. Similarly, in the switchgear control gear assembly, the other requirements which is related to earthing is in clause 9.1.2, power frequency withstand voltage. Because during a high voltage fault, the transfer potentials will be affecting in the low voltage side. The maximum limits are already defined in the standard. Now imagine the maximum power frequency stress voltage due to a high voltage fault is 1200 volt. Now your equipment must be able to withstand 1500 volt for a certain time. So this is of course related to the earthing. Impulse withstand voltage means during a switching action, how much voltage it is able to withstand. Protection of surge protective device. This is also something related to earthing. The most important point is SPDs shall be protected to prevent uncontrolled short circuit condition. The subject of SPD, they may be failing at the end of life. We say at the end of life of the SPD, it will create a short circuit, and the entire SPD along with its protective device, backup protection, must be capable of preventing uncontrolled short circuit condition. That means you are supposed to use an SPD with an integrated backup fuse, the best way. Now, in the standard 61439 part 1, there is an annexure C, user information template. Ideally, the user or the consultant on behalf of the user should be able to fill up the form, the annexure C, and give this information to the panel board manufacturer, so that he can make it according to your requirement. Now, here are the subjects of earthing. The first one, starting with the type of system earthing, which is explained in the standard clause number 5.6, 8.4.3.1, 8.4.3.2.3. Multiple clauses, the requirements are explained. So basically, the consultant who is designing the installation must fill up this particular format, and this is going to be the requirement of the client for making the panel board, switchgear, control gear assembly as per 61439. And the subjects are related to earthing is type of system earthing, transient over voltage, temporary over voltage, type of protection against electric shock, what kind of fault protection you are going to make, what kind of EMC requirements are there. Please note, the consultant is supposed to fill up this entire requirement, out of which few are related to earthing. See here, user requirement. The user should define what exactly you are going to do with this panel board and what kind of requirements are there. I just highlighted the requirement of earthing alone. So basically, there is a list of requirements for the panel board. So the equipment which you are using in a hospital is very important. Find out the requirement of the equipment which you are going to use. Find out the requirement or what kind of sources you are going to use, how many number of transformers, how many DGs, what kind of UPS, what kind of transfers are happening between these these different sources, what kind of electrical separation you are using, what kind of panel boards you are using, and as an overall condition, what is the concept of protection against electric shock you are making. Protection against electric shock is achieved by basic protection, fault protection, and additional protection. We have explained this in multiple webinars, so please go through the old webinars. You will be able to understand the protective measures required for basic and fault protection. Medical location need additional safety measure. That is very, very important. For that, what do we do? The medical locations are classified into group 0, group 1, and group 2 locations. I explained about this in the last webinar. Now, the classifications are very much included in the standard. The first subject or one of the subject which you cannot compromise is the protective earthing and protective equipotential bonding. That means you are creating an environment inside the hospital in such a way that potential difference do not exist. For this, the sizing of the conductor, the resistance of the conductor, the resistance of each of the joint, the touch voltages, all are important. The pictures, for example, this picture from a very old Indian standard, we have NFE had published our guide on electrical installation or guide for hospital safety audit. You can find this picture in the our guide, NFE guide for hospital electrical safety audit. So here, how to make equipotential bonding is very much explained. How to make equipotential bonding in a group 2 medical location is very much explained. How to use a medical IT system is very much explained. Unfortunately, there are companies, those who are supplying medical IT systems, and these companies are also demanding separate earth pit, which is absolutely wrong. So my advice to everyone who is in the medical field is, if any supplier, be it a transformer or a generator or a panel board or a lift or a medical IT system or a biomedical equipment, if any of these manufacturers are demanding a separate earth pit, the best way is you immediately conclude that this gentleman or this company doesn't have any idea of the electrical installation. So better you have to stop working with these companies. Otherwise, you will be in trouble. There is absolutely no requirement of separate earth pit in any of these locations. The subject of earthing, as I am explaining one by one, is a different subject. It talks about disconnection time. It talks about the touch voltages. Here in the picture, what you are seeing is you have a 230-400 volt system. You have the high voltage side, you have the low voltage side. For the fixed installation, main distribution circuits 50 volt, and for the group 0 location 50 volt, group 1 and group 2 locations 25 volt. These are the maximum allowed touch voltages allowed in these locations. So now, coming back to the subject, there are requirements for the medical electrical equipment. There are requirements for the supply system. There are requirements in the product standard. So earthing is a subject which is related to all these subjects. It is not about, making an Excel sheet, a calculation of fault current, assumed fault current. Sometimes I'm so surprised that sometimes people are not even able to understand the difference between symmetrical short circuit current between phases and earth fault current. 50 kiloampere, that is a symmetrical short circuit current. It has nothing to do with the earth fault current. But the whole design people wanted to make for 50 kiloampere, 65 kiloampere, and always based on IEEE 80 standard. Why I'm returning back to the same slide again is this is becoming a big challenge, because we are trying to explain, or we are trying to educate the market that look, IEEE 80 is applicable for a substation, not for a hospital, not for the low voltage electrical installation. But still, every day, 2-3 phone calls I used to get, and they wanted me to help with an Excel sheet how to make everything calculation for as per IEEE 80. So please note, this is not for a hospital installation. Fault current of 50-65 kiloampere, earth fault current of such large magnitude are very, very rare. And sometimes the biggest challenge which we are facing is the manufacturers, including biomedical equipment manufacturers, including earthing experts, the so-called earthing experts, those who are experts in chemical earth pit, digital earth pit. All these people together are making our installation really unsafe, very, very unsafe. Sometimes people start making large claims saying that I will make a big grid. And another disaster which we are finding these days are, example, for lightning protection system, there is a standard IEEE 62305. The standard very clearly explains what you should do during lightning, or how you can make an earthing system for handling lightning surges, or for handling or dissipating lightning current into earth. Now what happens is, if you are able to read and understand what is written in the standard, after showing the standard, people become experts in earthing, which is absolutely wrong. 62305 explains about the earthing requirement for lightning during the time of lightning, whereas the earthing requirement for a hospital, it depends, or the subject is explained in more than 50 standards. The standards which is related to the biomedical equipment, the standards which is related to the supply system, the standards are related to the high voltage installation, the standards are related to switchgear, control gear assembly, or UPS, and so on. So it is not a easy subject. Please note, I was mainly focusing on protective earthing. There is also a big subject of functional earthing. So we made this presentation just to explain you that during our last webinar, there were so many questions about earthing, but as the last slide, let me show one more time. Let me show the wrong concepts. Please don't make this kind of earth pit separate into your hospital. And in any hospital, if you have more than 1 or 2 earth pits, they are unsafe. So earthing is not a subject of making so many earth pits and connecting every electrical equipment into different earth pits. So basically, this is the end of the presentation. Probably this time we can have a much bigger question answer session. So let me stop sharing the slides. Over to you, Mr. Dominic. I hope the presentation was clear.
Yeah, it was the sound and presentation was visible quite well. So we have, I would request the participants who have questions, please post it in the Q&A box only, because there are plenty of questions I could see in the chat box. If you can type it in the chat box, we can take up one by one. And would you like to take it up, sir, or can you just difference between clean earth and power
Yes,
earth? First one.
I can take up one by one. The first is the
Yeah.
difference between clean earth and power earth. Okay, this clean earth and power earth was the old name. The new name is functional earth and protective earth. Functional earth means the earthing arrangement you are making in order to ensure that the entire electrical and electronic equipment are working properly or functioning properly. Protective earth means in order to ensure safety of the electrical installation, you are making an earthing arrangement so that the entire electrical installation is safe. So safety earthing and functional earthing, or protective earthing and functional earthing, is the correct word. So the second question is, equipment OEM are always asking to maintain the neutral to earth voltage less than 1 volt. Though we maintain the earthing as well, is neutral to earth voltage a measure of wellness of earthing? This is questioned by Dr. Somasundaram. Of course, it depends upon the type of equipment which we are using. Equipment are classified into class 1, class 2, class 3. Biomedical equipment, or ME and MES, are classified into class 1, class 2, class 3. And most of these equipment nowadays are having electronics and communication system. That means they are connected to a network. So it is communicating. The communication voltage is sometimes 2 volt, 3 volt, 5 volt, or 12 volt, very, very low voltages. And there is a subject of, let's say, clean earth means an interconnected system, nothing to do with earth pit, an interconnected system which ensures that zero reference is maintained all over the building so that the functioning of the low voltage, extra low voltage equipment are smooth. There is no potential difference and they will work very well. The most modern way of this functional earthing is called as mesh BN, mesh bonding network. That means protective and functional earthing are together, which offers very high reliability. Now, regarding this 1 volt, there are biomedical equipment working with 230 or 400 volt single phase or 3 phase. They have a reference plane for the electronics, and the reference plane is based on the neutral potential. Now, for a standalone equipment, even with 1 volt or maybe 5-6 volt, the equipment will work. But if two such equipment are communicating each other, and if there is a potential difference in the neutral between these two equipment, the communication, it will malfunction. There won't be any communication because both AC equipment working in 230 or 400 volt are using the neutral for the reference of the PCB. One of the solution is to keep the potential difference or potential built up in the neutral less than 1 volt. But please note, these are very old requirements. So these are already improved in most of the biomedical equipment. As I said, during the installation of the electrical equipment, during selecting the biomedical equipment, you should look into the requirement of all these equipment and you should understand and you should make a system so that your system is functioning properly. That means even if the neutral to earth potential is, let's say, 5 volt, 10 volt, the electronics is able to work. So the next question. What measures can be undertaken to assess and evaluate a hospital that has already been constructed and operational for a significant period of time? In an existing hospital, you have to assess the requirement. Again, the process is same. The type of biomedical equipment which you are using, the areas where you are using, the type of the example, the communication which is going on between the equipment, the type of oxygen content, all these measures which I explained in the previous slides, you need to assess, you need to find out the type of sources, type of changeover between the sources, type of backup system which you have, type of medical IT system which you have, and you have to assess all these things and decide on what kind of thing you are going to use. The best is you have to have a TNS system, because sometimes people claim that I want to make a TT system, two separate earth pit, one for the neutral and another for the body. A true TT system can never exist, because through the armoring of the cables, through the glanding, an inefficient TN system is made, and we think that it's a TT system. In a TT system, there shall be two electrically independent earth electrodes, which is practically not possible. So the best way is you make a Paka TNS system. Dr. Pandian, how many earthings are required for 1000 kVA, 11 kV bar 0.433 distribution transformer as per CEA regulation? If you are asking how many earth pits, I would say you need to have only one earth electrode. You have to have a common bus bar, neutral of the transformer, as well as body of the transformer must be connected to the common bus bar. The common bus bar can be connected to an earth electrode, and this earth electrode can be, the best is to have the foundation earth electrode. That means the steel which you are using in your construction. The second is probably you can have a horizontal ring. You can find this information in various of our previous webinars. Thank you for the question. So basically, to answer your question, you need only one earth electrode, even if you have 5 DGs and 10 transformers. Please give difference between group 0, group 1 and group 2 locations. So electrical categorization of medical locations are made in order to ensure that the patient as well as the environment is safe against electrical hazard. Group 0 is a location where biomedical equipment, let's say applied parts, are not used. That means the patient is not undergoing treatment. The biomedical equipment are not used in a location, and these are called as group 0 location. Group 1 is a location where applied parts are used outside the body. I'm saying an example. That means biomedical equipment are used, but they are used on the surface of the body. In group 2 location, biomedical equipment are used for life saving, to support the life of the equipment. The biomedical equipment are used. That is group 2. Sometime in group 1 and group 2 location, the applied parts are bypassing the skin and it goes inside the patient's body as well. These are very well defined. Last webinar, we explained it very much. Please go through that particular webinar content, which is available in YouTube, of course. Mr. Fernandez, I understand from your presentation, separate earth pit is not required for biomedical equipment. Absolutely, you are correct. Separate earth pit for biomedical equipment are absolutely not required. If any biomedical equipment supplier is demanding it, as I said, they are making a mistake. So please don't provide it. You look into the technical specification. Mostly if the equipment is an imported equipment, you look at the original manual. So the subject is very much included in the manual. So, Dr. Somasundaram, the question is, can you double click on what you said just before? Having multiple earth pit is not recommended. That means isolated multiple earth pit, but interconnected earth pit forming a grid is recommended. No. Oh, let me show it again. Let me show from my presentation. I'm sure you are able to see the screen. Let me show it again. So, isolated, separate earth pit is wrong. separate earth bit but connected as a group, clean earth, power earth. This is wrong. Separate earth bit as a group or individual and everything interconnected under the soil as a grid. This is also wrong. So these three are non-standard methods. So the subject of earthing is not about making lot of earth pits. The subject is about, let me show you the correct picture. The subject is about this one. This is the correct way of earthing. You can find this picture in National Electrical Code of India, 1985, National Electrical Code of India, 2011. Unfortunately, the 2023, this picture is removed. But this information is also a part of NFE guide on electrical safety audits in hospitals. So please have a look on these documents. You can find this particular picture, and this is how you must do earthing. So Shafiq Ahmad, how to measure earth pit current carrying capacity? Mr. Shafiq, please note that the earth pit is not, you are not going to inject current into the earth through the earth pit. That concept is wrong. The earth electrodes are used as a reference, system reference. Now let me show you one interesting point from the IS 3043 standard. You have to wait for a while. Just let me open the IS 3043 standard so that you can find IS 3043 2018. I am opening. Let me share it. So this is the standard. At the introduction of the standard itself, it's very clearly written. Here is the forward. As a matter of fact, the earth now rarely serves as a part of a return circuit. That means the earth electrode in soil is not to carry current as a part of return circuit, but is being used mainly for fixing the voltage of the system neutrals. The earth electrode is used to fix the voltage of a system. It is not a current carrying part so that you can inject some current through the earth pit. That concept is wrong. And always IS 3043 as well as all the all the electrical standards are explaining this particular subject. It's a misinterpretation that a lot of current will be flowing through the earth electrode. So probably maybe 10 amperes, 15 amperes, or maximum maybe 100 amperes will be flowing for a short time, not continuously. Mr. Janardhan is asking the effect of lightning arrestor on nearby electrical system earth. Of course, the lightning protection system must be bonded to the metallic parts of your building. Must. It is not, it's a must. You must connect. The idea here is, if you have two different conductive systems, there can be a potential difference. But you must ensure that the different, for example, the lightning protection system as well as the electrical system are interconnected in such a way that there is no potential difference. So it's always about how to avoid potential difference by, or how to create equipotentially bonded system, equipotential bonded. That means during lightning, there is no potential difference. As a result, there is no failure. So, Mr. Prasad Patnaik, how to prevent a short circuit in hospitals, as most of the fire takes place in ICUs and the storage rooms due to short circuit? Please note that short circuits may happen in electrical installation. It can happen because if you have a deteriorated equipment, maybe after some time it can create a short circuit. Short circuit is not the problem. Automatic disconnection is the problem. In case of a short circuit, let's say, for example, we say protection against thermal effect means during normal or abnormal operation of an electrical installation, once when the temperature goes beyond certain limit, the protective device should operate and the faulty circuit has to be disconnected. Short circuit is not the, I'm sure all of you are aware of the fire triangle. Fire triangle is a scientific way of explaining how fire takes place. It need oxygen, it need fuel, it need temperature. Electricity is creating temperature, or heat. Electricity is creating heat, and as a result of the heat, why the heat is because of the short circuit. So before conductive parts create are hot, you must disconnect the supply. It is not the short circuit, it is the disconnection which is much more important. Now, a question from Mr. Prabhakaran. For hospitality earthing, it's for residential earthing. Nowadays, ESE, early streamer emission lightning protection system, vendors are approaching to install in the building over conventional. Is it correct as per the standard? Mr. Jayaraman, please understand that early streamer emission is a non-standard method. Of course, there is a standard French code, NFC 17102. We have a webinar, and the webinar link is available in NFE website. If you go to NFE website, there is a blog. There are so many blogs which we made, and you can go through those blogs. One of the blog is about ESE lightning protection system. It's a non-standard system as far as India is concerned, and the National Building Code banned the usage of such a system. So, the next question, Mr. Balasubramani, if the source transformer is located more than 200 meters away from the building or load, and heavy motor-driven equipment such as chillers with compressors are installed, we have observed high leakage current during motor starting, with chiller body experiencing approximately 60 amps of leakage current. What is the appropriate technical solution, particularly with respect to earthing system, to mitigate this issue? Oh, this is actually a challenge which most of these modern equipment have got, because the modern electronics, which is operating with the semiconductors electronics, they have at the beginning they have a filtering system, and during starting of the filtering system, of course, there is a large amount of leakage current flowing. Please note the solutions. The remedies are already a part of the product standard. You have to strictly carry out the installation based on the recommendation of those standards. Example, if there is a variable frequency drive, the termination of the conductors, first of all, you must use special conductors, which is rated for VFDs. And those conductors, there is a sheathing, there is a kind of a shielding on the wire, through which this temporary leakage currents are flowing. Of course, there are remedies which is explained in the manufacturer's catalog. You have to strictly follow the manufacturer's catalog, and please avoid putting separate earth electrode in this case, because this is separate earth electrode is a disaster again. Question from Mr. Subrata Bera. Is separate earthing required for solar power? Is system and processing instrument to ensure electrical safety? Minimum Mr. Bera, please understand that separate earth electrodes are absolutely not required for any of the requirement. It can be biomedical equipment. It is including biomedical equipment, including different sources, including solar PVs, including lift, including UPS. Separate earth electrodes are absolutely not required. Everything must be a common connected to one earth bus bar. DG vendor and transformer vendors are asking body earth bit 2 numbers, neutral earth bit no numbers. Is it necessary? Again, I repeat, it is absolutely not required. It is a mistake. Don't do it, please. In regulation 43 of CEA regulation specified at least 2 separate and distinct earth connections with the earth for 415 volt metallic frames, neutral point and DG transformer to be earthed, the 2 separate and distinct earth connections. What is the way to ensure the same? Let me open up the regulation and show you what exactly the regulation is talking. You have to give me a second. I am opening the regulation to explain you regulation 43. So, CEA regulation number 43. This is the latest regulation. I'm showing the regulation 43 of the 2023 regulation. Neutral conductor of a three-phase four-wire system and the middle conductor of a two-phase three-wire system shall be earthed as per the relevant standard. Neutral conductor shall also be earthed at one or more points along the distribution system or service line in addition to any connection with the earth which shall be at consumer's premise. Please note that neutral, this is for the neutral conductor. In case of system comprising electric supply line having concentric cable, the external conductor or the armor of such cable shall be earthed by two separate and distinct connections with earthing system. Please note that there is a definition for earthing system. Earthing system is not, let me show you the definition of earthing system first, then I will take you through the this explanation. Earthing arrangement, the definition of earthing arrangement or earthing system is, it is not about earth pit or earth electrode. Earthing system means all electric connections and devices involved in the earthing of a system, an installation or equipment. All the connections, all the bus bars, wires, connections, all together is called as earthing system. Earth electrode is one of the component in the earthing system. So now again regulation 43. Here every building shall have protective equipotential bonding by interconnecting the exposed and extraneous conductive parts. Alternating system which are connected with earth as provided in the regulation shall be electrically interconnected. Of course, in these standards, for example, the frame of every generator, stationary motor, portable motor, and the metallic parts not intended as conductor, all transformers and other apparatus used for regulating, controlling electricity, and all electricity consuming apparatus for voltage exceeding 250 volt but not exceeding 650 volt shall be earthed by two separate and distinct connections with earth. Please note, not earth electrode. The definition of earth, the definition of earthing system is different. This means you have to have a common earth bus bar and you have to make two connections to the common bus bar. Let me show you one of the picture which NFE had published, or let me show you from my book, the missing link part 2, which is under preparation, which is under making. So now how to make so this is how you are supposed to make sorry, I can't return it. So what you have to do is, I'm sure you are able to see the picture. As you can see here, the DG or transformer, from its earth terminal, you have to have two connections to a common bus bar. So please note, it is not about earth pit. The regulation never explained about two separate earth pits. So you can find this very well in the standard. As in your question, earthing system. Earthing system means an interconnected system. It is not the earth pit. Please understand that. The next question is Neeraj Kumar Maurya. UPS system dedicated earth pit is required as demanded by the OEM. Mr. Neeraj, the OEMs are demanding separate earth pit mostly because they are unaware of what they are selling. They are unaware of their own equipment. Better you find out a good quality UPS supplier who knows the subject. That is the only recommendation I can give. If somebody has, I repeat, if any of these electrical, electronic equipment manufacturers are demanding a separate earth pit, be very clear that they don't know the subject. It is better to change the vendor. It is better to change your supplier. Now, the next question from Ms. Hemalata. if space constrained rock area after completing of building, how we have to design earthing system for all equipment, transformers, please note that the best way is you must think about electrical installation and you must think about earthing system at the beginning of your electrical installation, not after making the building. You can use or you can make use of the structural steel which is used in the building, and you can make a very good earthing and equipotential bonding system by making use of the steel with little bit additional modifications. So again, question from Mr. Sunil Kumar. Suppose the hospital 11 kV transformer location is very near to a substation with high fault MVA, then if a short circuit occurs on the hospital transformer location, a huge fault current will be pumped into the hospital location. For dissipating such huge fault current and for limiting the touch and step potential, how a single earth will manage the situation? I don't know what you are meaning by single earth. Please note, a huge fault current, a huge earth fault current will flow on the low voltage side of the system during a fault on the low voltage side of the system, provided you have a TN system. If you have a TT system, the fault current will be limited to few amperes or few tens of amperes. TT system means your transformer neutral is separately connected to an earth electrode. Your electrical main distribution board is to a separate earth electrode. Under that condition, the maximum earth fault current will be limited to few amperes or few tens of amperes, maybe 10 ampere, 20 ampere. So now you will have a very big fault current, earth fault current, if you have a TN system. Now in a TN system, the size of the protective earth bus bar or the size of the protective conductor has to be made based on the recommendation of the standard. The recommendation is up to 16 square millimeters, same size, 25, 35, 16 square millimeter. More than 35 square millimeters of phase conductor, your protective earth conductor should be 50% of the size of the protective earth conductor. Number two, after making the connection, so sizing of the conductor is important. After making the connection, you are also supposed to make a continuity resistance testing. You are also supposed to make a earth fault loop impedance testing. If you have done all the three, even if the earth fault current is 50 kiloampere, nothing to worry. Your system will trip within the time. So let 50 kiloampere current flow, but you don't need to worry because your conductors are sized for that. That is how it works. Please note, whatever I explained has nothing to do with the earth pit, because the earth pit, earth electrode itself is out of the circuit in a TN system. The next question, Anand Vijay Kumar, when electrical inspectors from the service providers insist a separate earth electrode for DC and multiple earth electrode for transformers, how do we tackle it? I would recommend, Apav sir, I am sure you are able to listen to me. I need your help also to answer this question.
Good morning, everyone. You have nicely conducted, and it's a repetition of things that we require. It's a myth, but we have to repeat again and again. Once our people know about the standards and the specific provisions, then only they will be aware. I have to provide the answer for this specific query. I have already posted a message in the chat box. Kindly note down those, copy paste and note down those references so that you can show it to the OEM or biomedical engineer or maintenance engineer of the company or even the electrical inspectors. There are no standards to recommend a dedicated earth pit. There are several standards to disregard this. So why all the standards are not recommending, but we are doing? It is because of practice and the long followed practice that is presumably due to the two separate and distinct earth electrodes concept misunderstood by the contractors, installers, and all the people. That is a disease that has come into the strongly imprinted in the subconscious mind of the practitioners. So that's become a practice for several decades. So once it becomes a practice, it is very tough to eradicate a disease. I can say this is a disease. Why I am saying is dedicated earth electrode. It's a misconception. Why? Because there are issues like conductor emissions, electromagnetic and electrostatic coupling. There is a potential existing between voltage source and earth. So this affects the referencing of sensitive electronic devices. See, medical diagnostic devices that can lead to malfunction because of separate dedicated electrodes. So without addressing the root cause of conductor emissions and electrostatic coupling and potential existing between the different earth electrodes, mutual coupling, we can't avoid neutral to earth voltage. Neutral to earth voltage can't be there once you provide the standard practices. So while one end of the communication device is connected to a local earth electrode and the other end is connected to the receiving device, which is referenced to a different earth electrode, a circulating current will exist that will cause the device to malfunction, especially in medical diagnostic devices, and the patients are more vulnerable to such circulating currents. Either the device will malfunction to show the incorrect result, or the patient will get microshock and even fatal during the surgery also. That's why the medical locations provide, group 2 locations provide a specific standards, specific criteria regarding the contact resistance between the equipotential bonding restricted to 0.2 ohms. So these are the things that we have already brought into the standards, and you can readily quote to the authorities what are all the standards which is against the misconceived dedicated earth. We let them go through the standards and regulations. So we are bound to standards, established practices, and regulations. When the regulator or the contractor or the biomedical engineer or the OEM engineers do not adopt, it's your right. I can't go beyond the standards. This is a thing that we have to take a well. So standard making bodies are working hard, but such misconceptions cannot be eradicated unless the stakeholders adopt established standards. That's my single message to the group today, because it's being repeated again and again.
Yes, we are repeating it again and again, that there is nothing. There is system, I think, TNTT IT system. A true TT system cannot, okay, a TT system can exist in a public low voltage electricity distribution. Other than that, if you have a DG or a transformer within your premise, and then a true TT system, it cannot exist. We are actually making inefficient TN system. So we have to make a proper TN system or TNS system. That is the best way. So in a TN system, the earth electrode itself is out of the circuit. So you don't need to worry about it. You need it to fix the voltage. So now Mr. Yavanti Kumar Bodia, please explain the material length and thickness of the earthing electrode for connecting the equipotential bonding plate to the ground. Mr. Bolia, if you are asking about the conductor sizing, the maximum conductor sizing from the common bus bar to the earth electrode is 25 square millimeters copper. If you are talking about the earth electrode, then you have to look into the table in IS 3043, IS 732, National Electrical Code of India, National Building Code of India, depending upon the different materials. Copper, aluminum cannot be used as earth electrode. Copper, stainless steel, or copper bonded steel, different sizes are recommended in the standard. Mr. Rajan Kare, again the question, LA system need to take separate earth pit? Absolutely no. It must be bonded to the electrical system. So Mr. Prabhakaran is asking copper or aluminum, which earth electrode is best? Mr. Prabhakaran, please note that aluminum cannot be used as earth electrode. Aluminum must be used only in exposed places. through the surface of a wall or in exposed places, not inside the soil or inside the concrete. Aluminium cannot be used in such application. So we have Mr. Kamlesh Kumar. Mr. Kamlesh Kumar is asking a detailed question. The first is a statement which says that CPWD, PWD, and their requirements are not or they are not harmonized and they are in contradiction. And he also says that I am always explaining that electrical audit is a non-standard name and it should be verification. Whereas we published a document called Electrical Safety Audit in Hospital. Why there is a contradiction? So please note, electrical safety verification is the correct word. We published a document and we named the document as Electrical Safety Audit in Hospital because in a lot of hospitals, the management, the people, those who are working in hospital, they started claiming or they started saying that, sir, we have an auditor and the auditor says verification is different. We need only audit. So the auditors who doesn't have any electrical knowledge, they started saying that audit is different, the verification is different, you do auditing. So that is the reason we purposely made the name of the document as audit. It is not in contradiction, it is very much explained in the contents of the document because people use the word audit quite frequently. So thank you for the question. Mr. Sheikh is asking, suppose after completion of structure earthing of one slab, we tested the resistance of one stud, but the required resistance is not achieved. So what is the solution then? I'm sorry, I don't know. You have to ask the supplier. If you are not achieving, you must achieve. You should get a guarantee from the manufacturer for an alternate method. So Mr. Vera is asking whether rod earthing can be used in CNG station. It can be used. What will be the specification? Mr. Vera, that is not the subject of today's seminar. Today we are focusing on hospitals, medical locations. Local authority, Mr. Abdul Ghaffur is asking, local authority requirement is earth resistance shall not be more than 1 ohm to achieve. We connect multiple earth electrode in series. Is it correct? It is wrong. It is not correct. It is wrong. The answer is achieving or some authority demanding 1 ohm earth electrode resistance is wrong. And now if you have multiple earth electrode and if you are interconnecting all the earth electrodes to achieve 1 ohm is absolutely not required. Don't focus into earth electrode, focus into safety. If neutral, Mr. Joshi is asking, if neutral and earth is short circuited in the internal wiring of the premise or some local inverters may cause it, how to tackle this problem? Mr. Joshi, please understand that inside the installation, that means after the main distribution board, neutral and protective earth conductors must be separate. Neutral has to be treated as a phase conductor. The minimum insulation resistance between the neutral and the earth conductor must be 1 mega ohm. So if you are violating that, of course, the chances of accidents will increase. So please don't treat neutral as a phase conductor and it must be insulated. So now Mr. Prabhakaran is asking, GI earth fits are used as earth electrode for residential building. Is it correct? Of course, it depends. You please refer the table in the standard. So I think with this we are almost all the questions are over. Mr. Sushant is asking when the part 2 of the missing link will be published. Of course, very soon. I need some time to finish it, but time is the biggest question, biggest problem. So we will be publishing it very soon. Thank you very much. So over to you, Dominic, sir.
Thank you, sir. Can you hear me, sir?
Yes.
Yeah, I don't know. My system is getting hacked, so no video there. Our next webinar is on 18th, that is next Saturday on data center, electrical installation and liquid cooling system. The speaker is one of the well-known expert from data center. So I would urge you to, we have already shared the link for registration. You may register. So we'll look forward to see you next Saturday for data center electrical safety. So thank you so much. We almost now covered 12, 1.5 hours time and a lot of questions been answered. Please become a member and keep getting, there's a lot of knowledge that you can learn out of our website and other information. We have a expert chat box in the WhatsApp. So if you're a member, you can continue to engage this conversation on technical conversation in the group. So look forward to see you.
Yeah.
And we have also shared the link to become a
Dominic,
member. Please do join.
Your voice was not very clear. Now there is one question where is operation theater required IT system? Now our systems are done with TNS. So the last question, I don't want to make a confusion here. Yes, medical IT systems are required for group 2 medical location. First you have to classify group 0, group 1, group 2 location, all group 2 medical location where vital body functions are supported by electrical equipment. You require a medical IT system. That means for those equipment which is supporting the life of the patient, you need a medical IT. Please note, it's not an IT system, it's a medical IT system. We explained it in the last webinar. So over to you, Dominic, sir. Probably we can finish.
I have my problems by using Lakshmi. As I said, we look forward to see you tomorrow, next Saturday for data center. It will be a very interesting subject. I would urge all the electrical engineer and consultant to join us. And the links are shared here. And also, I was requesting you to become a member of NFE because all the past webinars access, you can get the access. And also, we have a very the fantastic WhatsApp group where the technical questions have been answered. So if you have becoming a member, you have a lot of advantage. So it's just 1,000 rupees for a membership. Please do become a member. Website is also mentioned in the LinkedIn. In the link that is there in the chat box. Thank you so much. God bless you all. Have a wonderful weekend.
1 minute. There is a gentleman who raised the hand and he can talk. Mr. Shanmuga Reddy, if you have any question, you can ask now or probably.
Thank you for a very good session. Operation theater required IT system.
Okay, I think Mr. Shanmuga Reddy, that is by mistake. Probably we can finish the today's webinar.
Yes, sir. Thank you so much and have a wonderful weekend. We'll look forward to see you next Saturday.